So good morning. So Miss Pender has been starting off her videos with jokes, and Miss Pender's just way funnier than I am. So I'm going to start off with a Snapple fact. So I'm sure you can kind of see the Snapple fact there. It says, at room temperature, the average air molecule travels at the speed of a rifle bullet. That doesn't seem quite right to me, but, it's a Snapple cap fact, so it has to be true. So anyway, hopefully you all had a decent weekend and did something interesting and fun and safe, and you're all still safe, and it's now time to move on to some more interesting trig stuff. So I hope the video that I made yesterday was helpful for finding angles of, well, trig functions of any angle. Obviously, especially we're working with the special angles, 30, 45, and 60, and where they are in the different quadrants. So hopefully that is helpful, and we'll do more of that practice today. All right, so today we're going to be working on applying the knowledge that we have about trig values. So we're going to find angles, and we're going to find sides using our trigonometry. So here's our first problem. It says the angle of elevation to the top of a tower from an anchor point is 36 degrees. The anchor point is 120 feet from the base of the tower. How long should the support wire from the top of the tower to the anchor be? All right. So really what you should do for all these problems is just draw a diagram. That's really the best thing to do. So we have our little tower right here. And we have our little anchor point way over here. And we have our wire that's going to connect the tower to the ground to support the tower. And we know that the angle of elevation is 36 degrees. And we know that the angle of elevation, top of the tower, the anchor point is 120 feet from the base. So here's the base of the tower. Here's the anchor point. We got 120 feet right there. So what we need to know is, how tall is the tower? Nope, that's not what we need to know. We need to know, how long is the wire for the tower? So that's where the x goes, right over there. So we need to set up our trig function for this. So we need to figure out which of the three trig functions, sine, cosine, or tangent, are we going to use here. And so we know that from the angle right here, we have the adjacent, and we have the hypotenuse, and of course that means we're going to use cosine. So we got the cosine of 36 equals 120 over x. So this is all pretty simple. So we need to find the cosine of 36. So that's what I'm going to do right now. Cosine 36 equals, did that on my calculator, it's right there. Not that you can see it. It is 0.8090. So we have 0.809, we don't need to write the 0 there, equals 120 over x. Put that over 1, cross multiply. And actually, we can just really switch these, right? Because we can always switch the numbers on the diagonal of a proportion. So we have x equals 120 over 0.809. So 120 divided by 0.809 equals 148.33. 148.33 feet. And I'm going to recommend that you use 2 decimal places, and we'll just agree that's where we're going to go for our answer. Calculate with 4, and we would have right there if I put that 0 right there. So calculate with 4, round to 2, and we're all done. Pretty simple. You learn this in geometry. So same type of problem. So here we had an angle, and we went to find a missing side. Now we're going to have some sides, and we need to find an angle. So it says here, a drone is flying 50 feet in the air and is spotted directly over a house that is 200 feet away. What is the angle of elevation to the drone? So again, we draw a little diagram, and 50 feet in the air, directly over a house that is 200 feet away. All right, so we're going to be 200 feet away, and we're going to be 50 feet in the air. 50, 200. And all these are going to be right triangles because that's all we know how to work with for the moment. Later on in the year, we're going to find that we can use the laws of sines and cosines to work with any triangle that we want. Okay, so what we want to find is the angle of elevation right there. And so this is going to give us an opportunity to use our inverse trig functions, arcsine, arccosine, and arctangent. So let's figure out what we need here. So here we are at x, and these two sides represent, from the x point of view, the opposite and the adjacent. So opposite and adjacent means tangent. So we got the tangent of x is equal to 50 over 200. Or the tan x equals 0.25. So what we really want to find, though, is what's x. So we're going to take the arctan of both sides. So we know the arctan of tan of x is just x, because they cancel each other off. They're inverse functions, equals arctan 0.25. And on your calculator, it looks like this. Tan -1. And you're going to put in 0.25. So we'll do that right now. And so we got second tangent, 0.25 equals, we have 14.04 degrees. 14.04 degrees. Again, just did that on my calculator. Easy stuff. Okay, so that should be easy enough for the first two problems. I have a fun problem coming up here in a little while. Well, this is also fun, but not quite as fun as the other one. We got Romeo and Juliet coming up shortly. Okay, so a fire is spotted from the top of an 80-foot tower. The angle of depression from the tower to the fire is 15 degrees. How far away is the fire from the base of the tower? Okay, so again, I would draw our little tower right here. Here we are on top of the tower. There we are at the top of the tower, and we see that there is a fire that is, the tower is 80 feet tall, and we got this fire that's out here somewhere. We'll say we have a fire right here. There's our fire. And what we know is that the angle of depression, so the angle of depression is the angle formed by the angle, or by the sight line, in other words, the line to the fire here, the sight line, and the horizontal line. So the angle of depression in this case is the angle formed by the horizontal line and the line to the fire, and that is 15 degrees. But of course, we know that this horizontal line here is parallel to this one right here, and that means that this line right here is a transversal. And from back in geometry, you remember that alternate interior angles are congruent. So this angle here, the angle of depression, is really the same as this angle of elevation right here. So I'm going to recommend that you put the angle of depression inside the triangle instead of working with the angle outside the triangle. So now we have 15 degrees here, 80 degrees there. What we want to know is how far away is the fire from the tower? So again, we figure out in terms of this angle here, what's that and what's that? So this is the opposite, this is the adjacent. That means we're working with tangent. So we have the tangent of 15 is equal to opposite over adjacent. And we figure out the tangent of 15. So we got tan 15, and that is 0.2679. So we got 0.2679 over 1 equals 80 over x. And again, we can switch these two guys right here. And so now we have x equals 80 over 0.2679. So we'll just divide that out. So 80 divided by 0.2679, and we get 298.62. So 298.62 feet. That's how far away the fire is from the base of the tower. All right, so I'm just trying to move along here fairly quickly so we don't take up too much time in these videos. But here's a fun problem. So Romeo is 60 feet from Juliet's house. It's a little close, because remember, Juliet's dad is not happy about Romeo. Juliet's dad would rather that that Juliet be marrying, I can't remember his name, some other guy. So the angle of elevation to her dad's balcony is 32 degrees from where Romeo stands. And to her balcony, it's 40 feet. How far apart are the two balconies? So, again, a little diagram is going to be helpful here. So here we have Juliet's house. And here's Romeo over here. He's actually laying on the ground because he doesn't want to be seen. So he's there, laying there on the ground. And there are two balconies. There's Dad's balcony. Here's Juliet's balcony right there. So the angle of elevation to Dad's balcony turns out to be 32 degrees. And to Juliet's balcony, it is, what did I say? It was 40 degrees. So that whole angle there is 40 degrees. So what we're looking for right here is, I'm actually going to make this a little more helpful here in terms of where our triangle is drawn. So what I want to know is, how far apart are these two balconies right there? I want to know that distance. How far apart are the two balconies? So the easiest thing for us to do is find out how tall is Dad's balcony, how tall is Juliet's balcony, and subtract, which is exactly what we're going to do. So we got just kind of twice the amount of work to do. So, so let's call Dad's balcony, let's call that D for Dad's balcony. So we have this little triangle right here. So we got D, and we know that Romeo is 60 feet away, and we got 32. So D is from 32 is the opposite. 60 is the adjacent for 32. So we're again going to use tangent. So we got the tangent of 32 equals D over 60. So we find the tangent of 32. So tan 32 equals 0.6249. 0.6249 equals D over 60. And again, we do our little trick where we switch those two guys. Actually, no, we're not going to do that. We're actually going to cross multiply here. So we're going to multiply that by 60. So times 60 equals. And we see that Dad's balcony is 37.49 feet. D equals 37.49 feet. All right, now we're going to do the same trick with Juliet's balcony. And this time we're going to do the tangent of 40. I think that's what I said, right? 40 degrees, yep. And that's going to be, we're going to say J for Juliet's balcony over 60. And again, we're going to cross multiply. So we're going to find the tangent of 40. So tan 40 turns out to be 8391. So 0.8391 equals J over 60. And then cross multiply again. So multiply that by 60, and I know it's getting exciting because we're going to find out how far apart they are. 50.35. So J equals 50.35 feet. And then all we need to do is just subtract. Oops, sorry, that was out of range there. 50.35 feet and 37.49 feet. And we're going to subtract those. So 50.35 minus 37.49 equals, we have 12.86 feet. So 12.86 feet. So hopefully Juliet's dad's a little deaf, because 12.86 feet is not very far away. So when Romeo is calling up Juliet, Dad won't hear. Okay. All right. So speaking of romantic, we have Taya and Hayden. So this is going to be an awesome problem. So we have Taya and Hayden, and they're spending a nerdy romantic weekend week in Paris. They see the Eiffel Tower from where they stand, which, by the way, happens to be at one end of a soccer field. And note that the angle of elevation is 26.2 degrees. Weird, just like a marathon, 26.2. They walk to the other end of the soccer field, 360 feet, because international soccer pitches are 120 yards long, so 120 times 3 is 360. So this is all total reality right here. Directly towards the tower. The angle of elevation is 31 degrees. How tall is the Eiffel Tower? So I had to do some back calculation to make sure all these pieces of the problem work together to actually get us the correct height of the Eiffel Tower. So here we are. So again, we draw a diagram. So we're going to be having the Eiffel Tower right here. There's our Eiffel Tower. And so we'll just say that the top of the tower is right at the end of our right triangle here. And so we have two situations here. Yeah, and so when I say we, oh God, I have enough here. I don't know if I have enough room. All right, so when Taya and Hayden measure the angle of elevation from over here, they see that it's 26.2 degrees. Yeah, 26.2 degrees right here. And then when they get to here, the angle of elevation is 31 degrees. And we know that from here to here is 360 feet. This is a bit of a tricky problem here, because we don't know the total length from here to here, and we don't know the height of the tower, and we don't know either of these two guys. So really, this is a little more challenging than the other problems that we've done so far. So what we're going to do is we're going to include a little bit of a semi-unnecessary variable here. We're going to put a little variable right here. We're going to call this x to help us to get the entire length here so that we have something to work with. So let's work with our first triangle right here. And so we'll say that, cleverly, we'll say that the height of the tower will be h. I am probably going to need another piece of paper for this. So actually, I'm going to jump to another piece of paper. Okay, so same diagram. Just going to get the necessary pieces on here. And so this is going to be h, 31, 26.2, 360. Okay, so what we need to do is we need to find a relationship between these guys and a relationship between these guys, and then we'll see what we can do. It'll all come out nice. So in terms of h and x and 31, we can see that the relationship that we need here, again, is opposite over adjacent, which is tangent. So we're going to have the tangent of 31 equals h over x. And then we can see that the tangent of 26.2 equals h over 360 plus x. And so you note that we have two equations and two variables, and so we have a whole variety of ways of addressing this two equation, two variable thing. And so my recommendation is that we solve one of these equations for one of the variables and then plug that in. Or set them equal to each other or something, so we can eliminate one of the variables. So actually the easiest way to work this will involve taking an extra step, but it will be easier in the long run. So I'm going to recommend that we solve both of these equations for h and set them equal to each other, and that will tell us what x is, and then once we know what x is, we can figure out h. So that's going to be my recommendation. So let's solve this first guy here for x. I'm sorry, we're going to solve for h, so we're going to multiply both sides by x. So this first equation is going to become h equals x tan 31. And the second equation is going to become h equals 360 plus x tan 26.2. So the best thing for us to do is turn tan 31 and tan 26.2 into decimals. So tan 31 equals 0.6009. So we have 0.6009x. That's h there. And here we got tan 26.2. So tan 26.2 equals 0.4921. So we have 0.4921x plus, and then 0.4921 times 360, which gives us 177.142. 177.142. And so this is h, and this is h. So we can set these two guys equal, and that will get us the value of x. So we do that right over here. So we got 0.6009x equals 0.4921x plus 177.142. So then we'll just subtract that over to here. So 0.6009 minus 0.4921, 0.4921 equals 0.1088. So 0.1088x equals 177.42. Sorry, 0.142. And then we divide 177.142 divided by 0.1088 equals, and we got 1628.14. X equals 1628.14. Okay, so that is this value right here, 1628.14. So now we're going to use that to find that. And again, we're still working with tangent here. So tangent of 31 is h over 1628.14. So tan 31 equals h over 1628.14. We already know the tangent of 31 is 0.6009. So we got 0.6009 equals h over 1628.14. And we multiply that by 0.6009. 0.6009 equals I didn't multiply. So 0.6009 times 1628.14 equals 978. So h equals 978 feet. Well, because of some rounding issues that we didn't address really very well here, the actual height of the Eiffel Tower is 984 feet. And that's without the little radio antenna at the top. That adds a whole bunch more. But anyway, so 984 feet was the original height. So we were pretty close, but it's all about the rounding. So anyway, this is a fairly complicated problem. We had two variables, and we had to work the two variables into two equations, set the two values equal to each other, solve for x, use x to find h. So that is Taya's and Hayden's romantic adventure, nerdy romantic adventure in Paris. Okay, a couple more things to do here. Okay, a little less romantic. Well, actually, it'll just be the plane that they took. Hadn't thought of that. All right, during takeoff. Oh my God, it's 24 minutes. During takeoff, a plane's angle of ascent is 20 degrees and its speed is 300 feet per second. A, what is the altitude after 1 minute? And B, when will the plane be 10,000 feet up? Okay, so again, little diagram. We are flying like this. Angle of ascent is 20 degrees. And we know that the plane is flying at 300 feet per second. And we know that it's going to be flying for 1 minute. So we can figure out what the total distance traveled is in that first minute, and that'll be the length right along here. So 1 minute, of course, is 60 seconds. So we have 1, 8, and 1, 2, 3 zeros. 1, 2, 3 zeros. So we have flown 18,000 feet, and the angle of elevation is 20. So what we want to find now is what is the altitude right here. So from the angle, we have the opposite and we have the hypotenuse. So opposite over hypotenuse is going to be the sine. So we have the sine of 20 equals A over 18,000. So we're just going to multiply by the sine of 20. So the sine of 20 is 0.342 times 18123 equals 6156.36. So 6156.36 feet in the air. So that's how that's the altitude at 1 minute. We want to know when is the altitude going to be. What did I have here? 10,000 feet. So we can use this concept here and figure out when are we going to be at 10,000 feet. So we know that the A is going to be 10,000 feet, but what we don't know is what is going to be this angled distance upward. And we're gonna calculate this angled distance and then divide so we can get to the time. So we want the altitude to be 20,000 feet. So we're going to set up another little equation here. So the sine of 20 equals 20,000 over, I'm going to call that x, which is this length right here that we don't know yet. So x is going to be 20,000 divided by sine of 20. So 20,000, 1, 2, 3, divided by sine of 20 equals 58,476.09. So 58,476.09. So that's how far we had to travel along this length right here so that we could be 20,000 feet in the air. So now we're just going to divide this by 300 feet per second, and that'll tell us how many seconds we needed to travel. So we're going to divide by 300, and we have 194.92 seconds. So 194.92 seconds. We could divide that by 60, and we find out that that's 3.249 minutes, and that's going to be 3 minutes. And then multiply this bit here by 60. So minus 3 times 60, and we have 14.9 seconds. Okay, so that is some amount of time that I actually can't see. 20-something minutes. So we had a few more problems to do, but I'm going to call it right there. So yeah, hopefully you enjoyed the problems, especially the Taya and Hayden problem and the Romeo and Juliet problem. And I will see you guys on Wednesday. Be safe.